I've got questions 2 and 3 from this part of the worksheet up on the board here. Question 2, the parent function is x squared, and I ask you to specifically mark off the points whose x values are 0 and 1, and then graph g of x, which is 2 times the quantity x minus 3, that whole quantity squared. Question 3, the parent function is the reciprocal function. I ask you to specifically include the points whose x values are negative 1 and 1, and then sketch g of x. Now here I gave you g of x as 1 over 6 minus 2x, but I gave you a hint that you might choose to rewrite that. Remember here, we would do evaluating this using order of operations. We'd multiply by the negative 2 first, and then we'd add a 6 to that, because that's essentially a negative 2x plus 6. Okay? If we do that, we would do the transformations in the opposite order. So we would shift left by 6, and then we would do a flip and a shrink. It's no longer going to look like we've shifted left by 6. If you rewrite that, I always prefer to factor out whatever number's in front of the x. So if I factor that out, it becomes negative 2 times the quantity x minus 3. Now here, the first thing I would do in evaluating is subtracting 3. That means the last transformation will be shifting 3 to the right. And the graph will look like it has been shifted 3 to the right. Now, you don't have to. You can use either of these formulas. You just need to remember that when you're doing the horizontal transformations, you go against the order of operations. At this point, I need to mention that on page 190 of your textbook, there are two things, one of which is very good and one of which is very bad. There's a nice table at the top that talks about all the different types of transformations that we have. Does a really nice job of summarizing that. And then there's a table at the bottom that talks about the order in which you should do things. And the table on the bottom is wrong. The table on the bottom tells you to always do a horizontal shift first. The textbook is assuming that you are given things in this form, that you have not factored out a number. I am not promising that I'm always going to give you things in this form, and even when I do, I'm going to encourage you to write things in this form. The rule for horizontal transformations is that you go against the order of operations, working away from the parent functions. So the table on page 190 on the bottom, the one that gives you the order in which you should do the steps, ignore that. It is wrong. Okay? It's right if you assume that you never have things in this factored form, but let's not make that assumption. Let's just understand the order in which we do things and why we do. All right. So at this point, go ahead and pause the video. For both part B's, I ask you to keep track of the points that you plotted in part A. For question 3, I didn't explicitly remind you to keep track of where the asymptotes are. I'm now explicitly reminding you to keep track of where the asymptotes are. But I don't need to include that in written directions. If you are graphing something that has an asymptote, it is part of your job, and I don't have to remind you, it is part of your job to draw in those asymptotes. And if they're at a location other than the x or the y-axis, make sure you draw them in as dotted lines. All right, go ahead and pause the video, try and work these two out. I've got part 2a up on the board here. I've graphed our parent function x squared, including the points whose x values are 0 and 1. I didn't bother to ask you to include the point whose x value is negative 1, which would just be negative 1, 1 over here. That's because I know that the left-hand side is a mirror image of the right-hand side. So by having this point right here, that basically helps me to keep it so that I'm drawing it to the right scale, so that I haven't made it too tall and skinny or too short and fat, and I'm just going to remember that the left side is a mirror image of the right side. Now, for part B, we're graphing this transformation. So, in evaluating the function, I start with parentheses. So the first thing I would do is subtract 3. Then I would work with these parentheses. I would multiply by 2. And then I would square things. Then I would do the exponent. Okay, so I had 2 sets of parentheses and then an exponent. Now, squaring things, that's my parent function. That means these things I did before the parent function, so they're going to correspond to horizontal transformations. Subtracting 3 shifts things 3 units to the right. multiplying by 2 is going to shrink things by a factor of 1/2. Okay. And with horizontal transformations, I'm going to be going in the order opposite from the order in which I evaluate things. So I'm working away from the parent function. So I'm first going to shrink things by a factor of 1/2. So since these are horizontal, I'm changing my x values. Now half of 0 is still just 0, so that point's going to become 0, 0 still. But if I shrink that x value by a factor of 1/2, then instead of being at 1, 1, it's at 1/2, 1. So we've shrunk things horizontally. We've got a skinnier parabola now. And then I'm going to shift things 3 units to the right. So this vertex, which was at 0, 0, is now going to be at 3, 0. This point, which was at 1/2, 1, is now going to be at 3.5, or 7/2, 1. And I can connect those dots. So we've got our skinnier parabola shifted 3 units to the right. All right, let's go ahead and review question 3. So for question 3, the parent function, remember, was the reciprocal function. And I had asked you to include the points whose x values were 1 and -1. So we've got the point 1, 1, since the reciprocal of 1 is 1, and the point -1, -1, since the reciprocal of -1 is -1. Okay, so that's our parent function, and it has a horizontal asymptote on the x-axis and a vertical asymptote on the y-axis. So now we're asked to sketch g of x, which was 1 over -2 times the quantity x minus 3. I'm going to go ahead and use that version of the formula. So if I create my table for what I would do to evaluate the function, if I were plugging in a number for x, and then how that's going to correspondingly transform the graph, first thing I would do when I plug in an x is I would subtract 3, because that's in the parentheses, and I do parentheses first. Then I would multiply by -2. Once I have that number, I'm going to take the reciprocal. And that's my parent function. So, since I'm doing these things before I evaluate the parent function, I know these are going to be horizontal transformations, and I know I'm going to be doing these working away from the parent function. So instead of working top down, I'm going to be working bottom up for those. Subtracting 3 is going to move things 3 units to the right. Multiplying by -2 is going to be a horizontal flip and a shrink by a factor of 1/2. If I wanted to do that as 2 separate steps, I could, because I'm multiplying by -1 and by 2. -1 accomplishes the flip, 2 accomplishes the shrink, but since they're both accomplished by multiplication, I find it simplest to just do those at the same time. So, starting with my parent function, if I do the multiplication by the transformation corresponding to multiplying by -2 first, which is the flip and shrink, let's see what happens. So, the x value is going to get multiplied not by -2, but by -1/2. So I need to remember this is counterintuitive. Just like here, in order to shift 3 to the right, I'm not going to subtract 3, I'm going to add 3. So I'm always doing the opposite of what I'm doing in evaluating the function when I'm changing my x value. So if I take this 1 and I essentially divide by -2, or multiply by -1/2, that's going to become -1/2, and the y value is still at 1. Similarly here, if I take this x value and I do the opposite of multiplying by -2, so I divide by -2, that's going to make that +1/2, and the y value is still at -1. Let's see if this changed our asymptotes at all. Okay, so here, this was a horizontal line. Its equation was y equals 0. I'm not changing my y values. I'm doing horizontal changes. That's changing x values. So the horizontal asymptote is still on the x-axis. Here, the equation here I've got is x is equal to 0. Well, I'm changing x values, but 0 doesn't get changed when I multiply or divide it by a number. So my asymptotes have not moved in this case. So I still have a horizontal asymptote on the x-axis and a vertical asymptote on the y-axis. It's just these points right here, which I'll sort of informally call turning points, those have moved. Now I'm going to shift things 3 units to the right. So this point here, which had an x value of 1/2, now I'm going to do the opposite of subtracting 3. So I'm going to add 3 to that. So it's going to become 3½ or 7/2 -1. Here I had an x value of -1/2. I'm going to add 3 to that, again doing the opposite of what I do in evaluating the function. So that's going to become 2½ or 5/2. 1. Let's see if this affected the asymptotes. Here, the vertical asymptote was x equals 0. I'm adding 3 to my x values. The asymptote becomes x equals 3, which I'll draw in as a dotted line. The horizontal asymptote was right here. It had an equation y equals 0, and I'm not changing the y values. And graphically, I can see if I take something horizontal and I shift it to the right, it's the same horizontal line. It goes on forever, so shifting it 3 units doesn't affect its value. So my vertical asymptote has moved, but my horizontal asymptote is still the x-axis. So my transformed graph is going to look something like